You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we explore the foundational concepts behind virtualization, one of the most significant shifts in modern computing. Virtualization allows multiple operating systems to run independently on a single physical machine, enabling developers, IT professionals, and system administrators to test, deploy, and manage environments with far greater flexibility. This episode will help you understand how virtualization works, what components are involved, and how it appears on the ITF Plus exam. This topic is part of Domain 2 on the ITF Plus exam, which focuses on infrastructure and virtualization technologies. You can expect to see questions that ask you to identify the purpose of a virtual machine, define the role of a hypervisor, or compare virtualization with traditional physical systems. While the exam does not require you to configure virtual machines yourself, it does expect you to recognize the key terms and functions used in this increasingly important part of IT. At its core, virtualization is the process of running multiple independent computing environments on a single piece of physical hardware. These environments are made possible through software that mimics the behavior of hardware components. This technique allows for the creation of isolated systems, called virtual machines, which behave just like real computers. These virtual systems operate separately, but rely on the same underlying hardware infrastructure. A virtual machine, or VM, is a software-based version of a physical computer. It includes a virtual CPU, virtual RAM, virtual storage, and a virtual operating system. Within its environment, the VM can run applications, create files, connect to networks, and behave just like a real computer. The key difference is that it operates inside a host system, sharing its physical resources through virtualization software. To manage these virtual machines, systems use a special software layer called a hypervisor. The hypervisor controls how much of the host machine's resources like CPU time, memory, and storage are allocated to each virtual machine. It ensures that each VM operates in isolation from the others while sharing the physical hardware. The hypervisor is the engine that makes virtualization possible and comes in two major forms, Type 1 and Type 2. Type 1 hypervisors are called bare metal hypervisors. They run directly on the host hardware without needing an operating system. This makes them more efficient and secure for large-scale environments like data centers or enterprise servers. Examples include VMware ESXi and Microsoft Hyper-V Server. These platforms are used in professional infrastructures where stability and resource control are critical. Type 2 hypervisors are installed on top of a host operating system, just like a standard application. These are more common in personal or small-scale environments, such as classrooms or development labs. Examples include Oracle VirtualBox and VMware Workstation. While they are easier to set up and use, they tend to be slower and less efficient than Type 1 hypervisors because they must rely on the host operating system. The host operating system refers to the OS running directly on the physical hardware. This OS can manage files, applications, and devices as it normally would. Inside the virtual machines, guest operating systems run independently. These guests can be different versions of Windows, Linux, or even older systems. One host can support many guests, depending on available resources and the demands of each virtual machine. There are many advantages to using virtualization. It allows one machine to host multiple test environments, making it ideal for developers, students, and trainers. It also improves hardware efficiency by maximizing the use of system resources. Instead of dedicating one computer per task, a single powerful host can handle several tasks in parallel. Virtualization also supports fast recovery, easy cloning, and simplified backup for entire systems. Common tools for virtualization include VirtualBox, which is a free and open-source platform that supports Windows, Mac, and Linux. VMware offers both consumer and enterprise-grade tools, with options for hosted and bare metal deployments. Microsoft Hyper-V is included in some editions of Windows Professional and Enterprise, making it an accessible starting point for users exploring virtualization. These tools provide the platform to run virtual machines and configure their hardware settings. Virtualization is powerful, but it comes with limitations. Virtual machines may not perform as well as physical systems, especially if the host doesn't have enough memory or CPU power. Some software may not be compatible with virtual environments, and certain hardware features like advanced graphics may not be fully supported. When managing multiple virtual machines, careful resource allocation is necessary to avoid overloading the host system. It's helpful to understand the distinction between virtualization and emulation, especially for the ITF Plus exam. Virtualization uses real physical hardware resources, such as the host's processor and memory, to run virtual environments directly. Emulation, on the other hand, simulates an entirely different hardware system using software alone. Emulators are often used to run software from different hardware platforms, like console games on a PC, but tend to be slower and less efficient than virtual machines because they must replicate both hardware and software behavior. You'll encounter several specific terms related to virtualization on the exam. These include guest OS, which refers to the operating system running inside the virtual machine, and host machine, which is the physical device running the virtualization software. Other terms like image refer to a saved copy of a virtual machine's contents, while snapshot means a saved state of the machine at a particular moment. These definitions often appear in multiple choice or matching formats on the test. Virtualization is used in many practical scenarios. One common example is running Linux inside a virtual machine on a Windows computer, allowing users to experiment with a different operating system without affecting the host. Developers also use virtual machines to test software in multiple environments without needing multiple devices. Educators and students often benefit from virtual labs that allow hands-on practice without the risk of damaging the host system. A key feature of most virtualization platforms is the ability to take snapshots and perform rollbacks. A snapshot is like a freeze frame of a virtual machine, capturing its settings, files, and state at a specific point in time. If something goes wrong, like a failed update or system error, you can revert to the snapshot and restore the virtual machine to that previous state. This is particularly useful during testing or training exercises, where users want the option to undo mistakes. Virtual machines use a portion of the host's CPU, memory, and storage. This is called resource allocation, and it's a key part of managing virtual environments. If you assign too much memory to one virtual machine, the host and other VMs may slow down or crash. Conversely, giving a virtual machine too few resources can cause it to run slowly or behave unpredictably. Most virtualization platforms allow these settings to be adjusted before or after a virtual machine is started. Exam questions related to virtualization often ask you to identify terms or match a tool with its category. For example, you might be asked what a hypervisor does, or to choose between running an app in a guest or host environment. Other questions may describe a situation like testing software or isolating a risky file, and ask why virtualization would be helpful. Understanding these basic functions and roles will help you approach these questions with confidence. Importantly, the ITF Plus exam does not test advanced configuration or installation of virtual machines. You won't be asked to create virtual disks, configure hypervisor settings, or install operating systems inside virtual environments. Instead, the exam focuses on concept-level understanding, what virtualization is, what it is used for, and what terms and tools are associated with it. If you can describe the basics of how it works and why it's useful, you're well prepared. Most modern desktop and laptop computers support virtualization as long as the CPU includes virtualization extensions. These features must often be enabled in the BIOS or UEFI settings before virtual machines can run properly. On some older or budget systems, these features may be missing or disabled by default. Knowing how to check for virtualization support and whether the system is ready is a common task for IT support professionals. Virtualization also fits into broader IT topics like cloud computing and infrastructure as a service. In fact, many cloud environments rely on virtual machines to provide users with customized systems on demand. While virtualization and cloud computing are not the same thing, they share foundational technologies and terminology. Learning virtualization basics prepares students for more advanced exams and roles involving servers, storage, and remote computing. To summarize, virtualization allows you to simulate complete computing environments using software. Key terms include virtual machine, hypervisor, host operating system, and guest operating system. While you won't need to configure VMs on the ITF Plus exam, you will need to recognize these terms, understand the benefits of virtualization, and apply your knowledge to real-world use cases. Virtualization is a gateway to more advanced concepts in IT, and this foundational understanding will serve you throughout your career. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.